Hello, once again, folks. Welcome to the final section of Unit 3, 3.8, where we talk about box plots and outliers. All right, so we have our rule of thumb. We've been talking about it a few times, but I did mention before that there would be ways that we could quantify outliers. How can we draw a line and definitively say, yes, this is an outlier and this is not, without just sort of like assuming, you know? And here it is. So any values that fall outside of these fences, anything outside of these ranges. So lower outliers or anything less is anything less than Q1 minus 1.5 times IQR. And higher outliers, there's a little typo here, is anything above Q3 plus 1.5 times IQR. So again, follow these rules and you'll find outliers. That's what we're going to do here in our example later on. So a box plot is a visual representation of the 5-number summary. Now, what is the 5-number summary? The 5-number summary goes from the minimum, the maximum, and then the main things in between, which are Q1, median, and Q3. Fix that up a little bit. There you go. This is the 5-number summary, the minimum, the maximum, the median, and Q1 and Q3. And it should be in this order because this is the order that it should be in, right? The minimum will be the smallest, the maximum will be the largest, the median will be the 50% mark, halfway mark. Q1 is the 25th percentile or halfway between the min and the median. Q3 is the 75th percentile, which is halfway between the median and the max. So this order is important. It's easy to remember this order, 5-number summary. We've sort of done this before slightly, but we didn't really call it this before. But we've found all these things in the last section in 3.7. But now we're going to work with that. We're going to make a box plot of it. We're going to identify outliers from it. So we have some data here. We have the first 16 NBA seasons of LeBron James' career. And we have his average points per game scored for each season. So it says identifying the outliers. Okay, we can do that. So the first thing we're going to need to do is put these numbers in order from smallest to largest. So to do that, let's see here. The smallest one, I believe, is 20.9. Then followed by 25.3. It's actually two 25.3s. Followed by 26.4. 26.7. 26.8. 27.1. 27.2. Scoot over a little bit. 27.3. 27.4. 27.5. 28.4. Kind of running out of room here. 29.7. 30. And 31.4. Okay, just barely got in there. So these are all 16 values listed in order, smallest to biggest. And now what we're going to do is to find the 5-number summary, which is going to help us because we can't do the outliers without knowing these because I need to know what the IQR is. I need to know what Q1 and Q3 are. So I'm going to do the 5-number summary and that'll help me make the box plot anyway, but I also need that information to help with the outlier calculation. So there are 16 values here, which means it's going to be split 8 in the beginning, 8 in the end. So the median is going to be right between the 8th value and the 9th value. So 1, 2, 3, 4, 5, 6, 7, 8. So the median is going to be right here. No, wait, did I miscount that? Let me count that one more time. 1, 2, 3, 4, 5, 6, 7, 8. Nine, 10, 11, 12, 13, 14, 15. Did I miss a number? I think I might have missed one. Let me see. That's gonna be annoying. All right, I'll pause this real quick so I don't take up your time, but let me figure out what I did wrong. All right, I figured it out. I was missing a 27.1. There were 2 values there that are 27.1, and I only listed one of them. That was my fault. So if I count this again, there's 16 numbers here. So it's 8 and 8, the first 8 and the second 8. So 1, 2, 3, 4, 5, 6, 7, 8. So our first median is going to be right here. We have the first 8 values and the last 8 values. So this is the middle. And so if we calculate the average here for the median, 27.1 plus 27.2 and then divided by 2, we get the median of 27.15. Now we need the Q1. Q1 is the median of the first half. So there are 8 values here. So the median is going to be right here. It splits the first 4 values and the last 4 values. So the median of these two numbers, so adding these up and dividing by 2, we're going to get Q1 is going to equal 26.55. All right, so there's Q1. Now we'll go to Q3. Remember, Q3 is going to be the median of the second half. So these 8 values. So the median is going to be right between these ones. 4 values here, 4 values there. So this is Q3. And so you add these two up, 27.5 plus 28.4, and then divide by 2. This comes out to 27.95. All right, so there we go. We've got Q1, we've got Q3. Let's go ahead and calculate the IQR. IQR, remember, is Q3 minus Q1. So that's going to be 27.95 minus 26.55, which equals 1.4. All right, now for the outliers. So lower outlier. Remember the rule that we saw at the very top of the video here said that it was anything smaller than Q1 minus 1.5 times the IQR. So let's run these numbers real quick. So Q1 is 26.55 minus 1.5 times the IQR, which is 1.4. So if we run this calculation real quick, 26.55 minus 1.5 times 1.4, this gets us 24.45. So anything smaller than 24.45 is the lower outlier. Now let's talk about an upper outlier. Upper outlier is anything greater than Q3 plus 1.5 times the IQR. So if we follow this, Q3 is 27.95. We're going to add 1.5 times the IQR, which is 1.4. And this gets us 30.05. So anything larger than 30.05 is an outlier. And we do have outliers. That means that 31.4 is an outlier because it is larger than 30.05. And we also have a lower outlier, 20.9, because 20.9 is smaller than 24.95. So we have two outliers. We have one smaller outlier and one upper outlier. So what this does, by the way, in case you're curious, like you're a little lost, these create kind of boundaries, like cutoff boundaries. So anything smaller than this boundary is going to be considered an outlier. So it's a lower boundary. And this one creates an upper boundary. So again, these are boundaries. Anything beyond these boundaries is an outlier. Smaller than this or higher than that. So anything in between them is not going to be an outlier. And almost every value here is between 24.95 and 30.05, except for the 31.4 and the 20.9. So those are the outliers. Now we're going to make a box plot. So to make a box plot, we're going to start by drawing a number line. And this number line is going to go for me from 20 to, oops, not 30. It's going to go from 20 to 32 because our data goes from 20.9 to 31.4. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, that should be good enough. 21, 22. Just number these real quick. All right. Now this one's a little unique because this one does have outliers, but let me show you real quick what a box plot normally looks like without outliers. So here's two box plots. We're gonna get to these in a second. James his box plot has two outliers. You can see that with the points, but Jordan's here doesn't have any outliers because it doesn't have the points. So Jordan is a more typical box plot. And what you have in Jordan's box plot is you'll have 5 markers. You're going to notice one here, 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 and here. These 5 markers in a box plot are the 5 number summary values. So this is the minimum. This is the Q1 value. This is the median. This is the Q3 marker. And this is the maximum. So that's typically how we'll do it. But remember, so Jordan didn't have any outliers though. So with outliers, it's a little different because the outlier here would normally be the minimum. But because it's an outlier, we're going to separate it from the rest of the box plot. So the second lowest value is actually going to be our minimum mark. And the same thing up here. This is the maximum, technically would have been the maximum. But because it's an outlier, we're going to create the second highest value as our maximum. So that's what we're going to do with LeBron's here. So we have an outlier at 20.9. So it's going to be right here. We have an outlier at 31.4. We're right about there. So again, I'm putting these just above the number line. Again, kind of similar to how this one was made. All right. So since those are outliers, I'm going to have the next smallest number be the minimum. So 25.3. 25.3 will be right about here. Then Q1's at 26.55. So about 26.5 right here. Then our median at 27.15. So a little bit past 27 right there. Then Q3 at 27.95. So pretty much 28 nearly. And then our new maximum without the outlier is at 30. So we'll have a maximum of 30. So these are the 5 number summary values. And so remember, this one was the new minimum. This one was Q1. This one was the median. This one was Q3. And this one was the maximum. So to make a box plot, we make a box going for the IQR, the interquartile range. So from Q1 to Q3, we'll connect that to make it a box. So the quartiles connect to make a box. The median should be somewhere in the box. And then we'll draw little whiskers that connect the endpoints, the min and the max. And that is your box and whisker plot. And it's basically what we have here with James's box plot. All right. Now there's something really important that I want to point out. And that's, notice the separation, right? Notice my numbers up here. Remember my numbers listed in order? Remember, there are 16 numbers, right? In total. Notice that there are 4 values here. There are 4 values here. 4 values here. And 4 values here. 4 out of 16 is 25%. So this is 25% of the data right here. This is 25% of the data. This is 25% of the data. And then this is 25% of the data. So that's how the box plots work. Everything here works. They're cutting everything into quadrants, right? So that means that right here this is 25% of the data. This right here is 25% of the data. This is 25% of the data, and this is 25% of the data. So that's how a box plot is structured. It's structured to break it into fourths. Now, they're not always going to be like equal length. For example, look over here at Jordan's. Let me erase this real quick. The stuff that I wrote on it before. But you're going to notice with Jordan's box plot how this region here is shorter than this region here. And it doesn't mean that there's more values. A lot of times people think, oh, it's longer because there's more values there. That's not true. This is still 25% of the values, and this is still 25% of the values. The reason this leg is longer, though, is because these values are more spread out, right? There's probably 4 values here, but these 4 values are more spread out than these 4 values. And it's more spread out than these 4 values. So again, it's always 25%, these regions. It's just the lengths are different lengths because of how spread out those regions are. So a longer leg like this, a longer whisker, means that these are just more spread out. It's the same amount of values as anything else. It's just they're more spread out values. All right. But there you go. There's your box plot for LeBron. So now we're going to jump back into this one, and we're going to compare LeBron's with Jordan's. It says compare the distributions. So when you compare the distributions, that means we are going to socks it up. Okay, so shape, outliers, center, and spread. So we're going to start with shape. Now, Jordan, what I like to do, let's look at Jordan first. So notice, remember the median here is the halfway mark. Notice how this half is longer than this half, right? That tells me that this data is slightly skewed a bit more to the left, right? It's a little longer tail on the left side. So that tells me it's skewed to the left a little bit. So I think Jordan is skewed to the left. Now, if we don't count these outliers for LeBron, then here's a halfway mark. I notice that the right side is a little longer than the left side. So LeBron's is slightly more skewed right. So if we're talking about shape, they're both slightly skewed, but I think slightly skewed in opposite ways. So LeBron is slightly skewed right. And Jordan is slightly skewed left. So shape, let's go into outliers next. Outliers are easy to identify. James, as you noticed, has 2 outliers. These dots are outliers, but Jordan doesn't have those dots. Jordan doesn't have any outliers. So James has 2 outliers at 20.9 and 31.4. Jordan has no outliers. All right, now we'll talk about center. So we mentioned this in several other videos, but depending on the shape, this will dictate which type of center we talk about. So we have a lot of data here, and we have 2 values that could measure center. Median measures center, and then mean measures center. So should I compare the means, or should I compare the medians as my center? Well, remember, it goes back based on the spread or the shape. So because these are skewed distributions, if it's ever skewed, we would rely more on the median than the mean. So we're going to compare their medians. So James has median of 27.15. Jordan has median of 30.10. And then lastly, the spread. So we also talked about this in the last video, but there are 2 measures of spread that we have up here. We have standard deviation and we have IQR. Remember, depending on what shape the distribution has, it will will dictate which one of these we use. And because again, it's skewed left and skewed right, that's going to be the IQR that we're going to trust more than the standard deviation. And that, remember, IQR goes hand in hand with median, and we used median as our center, so of course we're going to use IQR as a spread. These things, like I said, go together like peanut butter and jelly. So spread. So as you can see visually, look at Jordan's. Jordan's data is much more spread out than James's, right? James is very much more compact with a couple outliers. Jordan is much more spread out. And you can see that in the IQRs because James's IQR is much lower. It's 1.4, whereas Jordan's is much larger at 5.7. So this tells us that James's spread is very small and Jordan's spread is very large. And we can see that too in the pictures. So James has smaller IQR of 1.4. Jordan has larger IQR of 5.7. All right. So again, socks, shape, outlier, center, and spread. Just remember center and spread that are dependent upon the shape. So if it's skewed, you're going to use median and IQR. If it's symmetrical, you would use mean and standard deviation. All right. And again, all those values were there. All right, but that's going to sum it up for this video. I'll see you guys in the next one. Bye for now.